So today you're going to do a lab, and what you're going to have to do is use this bottom table. And if you want to write these down, you don't have to. We're just doing some examples. But use this bottom table. There's two things that can happen in the lab. When you put the drops together, okay, when you put the solutions together, they'll stay clear. And if it stays clear, there's no reaction. Okay? There's no heat given off, no bubbles form, no precipitate form, no color change. If it changes color, then that's a precipitate that's being formed. Really, really fine particles of the solids being formed. It looks like it's just a change in color, but there's really fine particles that are being formed. So if it changes color, then you got a precipitate that's going to form. We call that substance insoluble. When two liquids get together and they form a precipitate, we say that there's some ions in there that are insoluble with one another. So insoluble means they'll form a solid. Okay? So I've got this kind of rewritten as instead of the names, I've got them rewritten as the actual ions so that you can see the ions over here. Because if you're not sure what a nitrate is or a chlorate is yet, or a sulfate, I have those written in there. So this is the same as your chart. What I've done is I've outlined these top four. These top four say, for the most part, these solutions are soluble, but there are some exceptions on 3 and 4, and we'll talk about those. And then 5 and 6, we take it from the point of view that these ions are insoluble. Okay? So we're going to go through this. We're going to go through that table and look at number 1. And number 1 says sodium, potassium, ammonium compounds are soluble in water. So if you have any of these ions present, sodium, potassium, or ammonium, in number 1, they're going to be soluble. Okay? So let's look at our list. Do we have any of those listed in our examples here? Yes. Okay, which one? Okay? The which one? Third one. Okay. So if it's soluble and we have a K out in front, we write AQ. AQ means that it dissolves. Okay? Any others on the number 1 list? Sodium, potassium, and ammonium. Anything else there? Should be, right? What's another one? Na2S. Na2S? Okay, so that's aqueous.
The one on the right.
Okay, because of the ammonium. Okay, it's aqueous. Any questions about that? So, anytime you have any of those ions present, it's going to be aqueous.
So the one on the way bottom would be aqueous?
This one?
No.
Oh, this one?
Yeah.
Yeah. Okay. So, number 2 says if you have any of these ions here present, it's going to be soluble. Okay? So, do you have any of those ions present in some of the other ones listed?
Yes.
First one, nitrate. Anytime you have a nitrate, that's aqueous. Okay? Anything else? So, if you have 1 and 2, those ions in any compound, you're just going to write AQ. Automatically, you look at it, boom, AQ. That's pretty easy. All right? Now, 3 and 4 have exceptions. 3 says, chlorides are pretty soluble, but if we put them with silver, lead, and mercury, they are not soluble. They form a precipitate. Number 4, sulfate, pretty much soluble, but they have 5 ions. If they're present with them, they'll form a solid. Now, those are barium, strontium, lead, calcium, and mercury. So do we have any combinations of chloride or sulfate that we can go ahead and determine if they're aqueous? Or if they're precipitate, we're going to write an S because it forms a solid. So are there any along those lines? Which one?
The bottom.
BaSO4. So we look at SO4 and it said, hey, they're soluble. But if it's with barium, which it is, we say that it's insoluble, and so we're going to write an S for solid. Makes sense? So these 3 and 4 says, hey, you know, these are pretty much soluble all the time, but there are exceptions. And those are the exceptions right there. You have them written down. Are there any others that we can look at?
The first one.
This one? This is an exception, right? Because chlorides are pretty much soluble, but we have silver, and it's with silver, so that's a solid. Make sense? We have any others? Aqueous, right? Because it's not with lead, silver, or mercury. They used to call these the heavy metals. When we used to do labs, we used to use mercury, lead, and silver, and we used to separate them. They used to call the heavy metals or group 1 metals. These are pretty much nothing. You don't want to put any of these down the drain. So that's why we have those containers that you guys pour everything into. Even though maybe we'd have very limited amount of one of those 3, we still put them in there. We don't want anything to go down the drain because they don't dissolve real well, and they can get back in your drinking water supply eventually, possibly. We wouldn't want that. Okay, so FeCl3 would be aqueous. Okay, questions on any of those? Now 5 and 6, they take it from the point of view they're insoluble, but in the case of carbonate, phosphate, and silicate, Na+, K+, or NH4, which is group 1. So they're kind of repetitive on that. They're saying, you know, these are going to be insoluble unless they're put with one of group 1. Well, you already knew that, so, but they're going to be pretty much insoluble. Do you have any that we can write? Number 5 is aqueous or solid. This one?
Yeah.
And that one's a solid. Okay? And then the last one is sulfur. And sulfur adds in a few more. It's your sodium, potassium, and ammonium. But sulfur is also soluble with calcium and strontium. So if you have calcium and strontium present. Now if you guys want to write down those ions on that list, I don't have a problem with that. Where you have sodium, write Na+, calcium, or potassium, write K. I'll leave that up there. But I think that's an easy way to look at it, like this. I took that one out of the book, and so questions you have? Yes, Ashley.
So for like number 5, so if it's the like CO3, but then it's paired with like Na or K, then it is the AQ.
It's aqueous. It's aqueous. You could also look at list 1. So this is probably not, the reason for 5 is these saying that they're insoluble, and then number 1 will take over. So soluble always takes over. Okay, if you have anything in 1 and 2, they're always aqueous, no matter what. Okay? Now, what's the reason for this? You say, well, what are we going to do? Well, if it forms a precipitate, we know it's a reaction. So we're going to give you 2 examples where we have a reaction and we don't have a reaction. Okay? Like we did with single displacement. Something real similar to that. All right? So I'm going to go ahead and write 2 of these down, and then we'll talk about what's going on with these reactions. These are called double displacement reactions. Okay, that's we did single displacement. You got a single element by itself. Well, it may displace, it may not. We have double displacement reactions. So we'll go ahead and do a couple examples of double displacement. Okay, I'm not going to tell you what your products are. And this here, we call it double displacement. And double displacement, the positive ions replace the positive ions. So we got a positive here. We know this is a negative. I'm not going to tell you exactly what the charges are, but we know it's positive. Chlorine's negative. Potassium's positive. Carbonate's negative. Okay? So only the positives or the metals and ammonium can replace one another. So that's what happens. This Ba comes in, K will be kicked out from carbonate, maybe if it's a reaction, but we'll have to still write it. And then it will go where Ba is. So it's called a double displacement reaction. Any questions with that? Positives can only replace positives. Okay? So then I got to put Ba with CO3. So K is now displaced. We got Ba CO3. Some of you are still struggling. I hear you talking. Why does that 3 go over? Why doesn't that 2 go over? I'm not understanding what. You just write one of each. Then you look at their charges and you determine how many you need. So Ba is a +2, carbonate's a -2 on your list. So we'll leave that, and then we're going to go ahead and put our little brackets here so that we can determine what it will be by our solubility rules. Then the next thing we do is we take K and put it with Cl. We check our charges. Potassium's 1, chlorine's a -1. They're going to go together 1 to 1. Okay, so now we go to our list. BaCO3, what is it? Is it aqueous or solid? So we find CO3, number 5. We don't have any ions present with carbonate. We have barium, so that's a solid. And then we look at KCl. What is it? Aqueous. Then once you do that, you just balance your reaction by putting a 2 in front of KCl when you're all done. Now, you know it's a reaction because you form a solid where we didn't have a solid beginning with. So anytime you form a precipitate, it's called a reaction. Does that make sense? So anytime I get a solid on this side, it's a reaction. I know it takes place. Okay? So I'm going to give you another scenario here. All right?
I have a question.
Yes, ma'am.
So what if you start with a solid on the left side?
We're not going to have all our liquids are solutions. So they're all aqueous to begin with. So everything's aqueous to begin with.
So it'll be like easy to know if... Okay.
Yeah, I mean, when I write them out, they'll all be AQ. So everything I write out for you for testing or for you guys writing out, when you guys write them out, they'll all be AQ. Right, you'll know all these when you have to write them out.
Okay.
Yep, they'll all be AQ.
And then one more question.
Yep.
If we write down like the number 1, 2, 3, 4, whatever up there on our sheet, can we use our sheet on the test then?
Yeah, I don't see any, I mean, that's the same information, it's just in the ion form. So it's probably a little bit more helpful than just, yes.
Do we need to know that for tomorrow?
No.
Or do we just need
No. So your single replacement reaction we've been working on for about 3 days, off and on, and we did a lab on it, is on this. Okay, so this is brand new material, right? So I'm not going to be testing or quizzing on that until later. All right, so the next one we'll take a look at. Let's go look at this combination here. You guys go ahead and practice that, and then I'll write it out here in a second. So it's a double switch. Write your double switch. Some of you, again, you're wanting to transfer the subscripts over, and you won't on these unless they're a polyatomic ion. Then you have to keep it together. If it's a polyatomic ion, like the CO3 on this first one, we had to keep it together because that's what makes carbonate. Carbonate is CO3. Okay. This one, SO4, has to transfer over. Okay, it can't be separated out. Sulfate is, you can't separate out. So go ahead and rewrite that and see what you come up with.
With these, does it matter where K and Mg fall on this table, or do you always...
Okay, so the top table is for single replacement, and the bottom table is for double displacement.
Okay.
So yeah, we separate the two. One's single, one's double. So the bottom one's double. So you would not look at the top list when you do these. You don't want to look at that list. Yes?
So would we ever have like no reactions with this?
We could. And then I'll go ahead and explain that. So this one, you have K go with Cl, and the charge is balanced. And so we'll put a value, we'll put aqueous or solid in there once we figure it out, and we come to a consensus. And then we put Mg with SO4, and their charges balance out too, because magnesium's a +2 and sulfate's a -2. So we look at KCl. What is it? Is it aqueous or solid? Aqueous. Because of both the K and the Cl. You got two things there, you know. So it's aqueous. Okay, what about the MgSO4? So these are soluble except that they're barium, strontium, lead, calcium, or mercury. So what would that be? It's aqueous, right? Is magnesium there? If it was put with barium, it would be a solid. If it was put with strontium, it would be a solid. But it's not put with any of those five, so it is aqueous. Sulfates are kind of, people mess up on that because they think, but it's soluble. So it's AQ. Now, if we put these two solutions together, are you going to get a solid form? No. So is there a reaction there? No reaction. No reaction. This would be a no reaction because we have nothing new form. It's just mixing ions. If you just mix ions and you don't have a precipitate, it's called a no reaction. So you can have those that if they're both aqueous would be no reactions.
But with these, you still have to do the work to find out its reaction.
You do. Some students get really good at it, and what they'll do is they'll go, all right, before I do this, I'm going to put K and Cl. I'm going to look at it. KCl, Cl is present, soluble, so is potassium. And then they'll go MgSO4. I know those go together. Mg and SO4. Oh, that one's soluble. And then write no reaction. So there's some that can look and see. Others would have to write it out just to double check, to make sure. Yes?
So what if there's two solids, or is that impossible? Is that no reaction?
Oh, it could be. That's very rare, but it could be. You could have two. You could have two solids, and if they're both solids, then yes, it definitely would be a reaction.
Okay.
Yep. There's a couple cases. There's one that's an acid-base reaction that you form two solids, which is kind of cool. But yeah. Okay. So I'm going to go ahead and